Hey everyone, bet you've heard the buzz about AWS Trainium 2, that new AI chip everyone's talking about.
Um,
Today we're going to really dive deep into it, figure out what it is, why it matters, and is this the moment for AI, Like picture this, 16,000 crazy powerful gaming PCs
wow.
running nonstop 247 for 70 days straight. That's the kind of power we're talking about, which is one Trainium 2 cluster.
It really is incredible, the sheer scale of it. And you know what's
Mhm.
fascinating? It's not just about building something massive. It's about why they did it. It all comes down to AI models.
Right.
They're growing like
Yep.
crazy. And the more complex they get, the more compute power they need. It's like insatiable.
I hear you, but sometimes I get lost in the lingo. Like scaling AI sounds cool, but what's the real world impact of making these models bigger and bigger? Does it actually make a
Oh,
difference?
absolutely it does. Basically, it boils down to intelligence. Think of it like this. The bigger the model, the smarter it gets. It can do more complex things, give you more nuanced answers, and be way more accurate. But here's the catch. That jump in accuracy, it doesn't come cheap. A tiny improvement, like 1.5x, can demand a 10,000x increase in compute power.
No way. I read that in the source material. 10,000x. That's wild. That's exponential, right?
You got it. And that's exactly the problem Trainium 2 is tackling. It's built from the ground up to handle those crazy workloads. But it's not just tea about brute force.
Yeah, I was looking at the specs. 1.3 petaflops, 96 gigabytes of memory, bandwidth of 2.9 terabytes per second. I mean, those are huge GE numbers, but do they translate to real-world performance? Does it actually make a difference in how AI works?
You're right, raw power is important. But different AI tasks, they have different bottlenecks. Think of a chatbot. Processing what you type in, that's super compute heavy, but then generating each word in the response, that relies a lot on memory bandwidth. It's like a car.
Okay.
You need a powerful engine, but you also need a transmission that can handle all that power.
So it's got to be balanced.
Exactly. Trainium 2 is designed to excel at both compute and memory bandwidth. It's a versatile chip, ready for whatever you throw at it.
I got to ask about this. I was reading how they compared Trainium 2's design to a vertical city power grid. Like what?
It's a cool analogy, right?
Yeah.
So think about traditional chips. They spread out the power delivery kind of horizontally, which, can lead to some inefficiencies.
Like wasted energy?
Yeah. Trainium 2 stacks things vertically. It's like building a skyscraper instead of sprawling out.
Mm-hmm.
This improves power integrity and boosts efficiency by, get this, 30 to 40%.
Wow. So it's more compact and efficient.
Exactly. Imagine your lights dimming when a powerful appliance turns on. That's kind of like what happens in some chips. Voltage drops.
Oh, yeah, I've seen that.
Trainium 2 minimizes that, so it's way more stable and efficient.
Gotcha. So they've built this amazing, efficient chip, but does it deliver?
Well, the proof is in the pudding. Anthropic, they're a big AI company. They tested Trainium 2 with their Claude model. They saw a 60% reduction in response times, up to 125 output tokens per second. And get this, 1.7x lower training costs compared to using GPUs.
Wow, those are some serious gains. But is this just for the big guys? What about smaller companies or, regular developers? Can they get in on this?
That's a great point. It's not just about speed for the tech giants. It's about making powerful AI accessible to everyone. More affordable, too.
Huh.
This opens doors for smaller companies, researchers, startups. It's like democratizing AI.
I love that idea. Okay, now for the techie stuff. I gotta ask about sparsity. It's mentioned in the source, but I'm kind of lost on that one.
Sparsity, huh? Okay, picture a busy restaurant, right? Sparsity is like the waiters only focusing on the occupied tables, not wasting time checking the empty ones.
Ah, so it's about skipping unnecessary steps, like
Yeah.
working smarter, not harder.
Precisely. Trainium 2 compresses data, ignores zeros, and boom, up to 4x speedups without losing accuracy.
So it's like we've been using a giant truck to deliver a single pizza. We needed a scooter.
Exactly. And with this efficiency, who knows? Maybe we can build AI models that were impossible before. It's a whole new world of possibilities.
Now, things are about to get epic. The source mentions Project Rainier, AWS and Anthropic teaming up, linking hundreds of thousands of Trainium 2 chips, 5 times bigger than anything before. We're talking hundreds of exaflops. Can you even wrap your head around that? What does that even mean?
It's mind-blowing, isn't it?
Yeah.
It's like almost unimaginable power. This could allow us to train models so complex, so advanced, they were literally unthinkable before. Who knows what we'll discover, what breakthroughs are waiting to happen?
It's like stepping into a whole new era of AI, right? But with all this power, it still needs to be usable. For developers, I mean. That's where the Neuron SDK and NetKI come in.
Yeah, got it. NetKI, the neuron kernel interface, lets developers write super optimized code that takes full advantage of Trainium 2's hardware. It's like giving them the keys to a Formula One car.
I read about a team at Amazon who used just 77 lines of NeckAI code and got an 18x speed up in their Mamba 2 model. That's crazy. That's the power we're talking about.
Absolutely. And to top it off, Anthropic used their Claude AI to actually write a kernel for Trainium 2. AI building tools for AI. How wild is that?
That's mind-blowing. It's like AI is becoming self-aware or something.
It highlights just how flexible and programmable Trainium 2 is. It's not just hardware engineers innovating now, it's AI developers pushing the limits of what's possible.
So we've seen the why behind Trainium 2, the tech itself, and even a glimpse of what it can do. But there's so much more to uncover. Let's dive deeper into how it works, what makes it so unique. This is just the beginning.
We've talked about how powerful Trainium 2 is and what it can do. But how did they actually build this thing? It's a real engineering marvel, designed specifically for AI workloads.
Yeah, the source material mentioned something called systolic arrays, which honestly sounded kind of medical to me. Can you break that down? What are they and why are they important?
Systolic arrays. Think of it like an assembly line, but for calculations. It's a grid of simple processing units, each doing basic math, like multiplying or adding. And they pass data along to their neighbors in a synchronized way.
So it's all about streamlining the flow of information.
Exactly. This design has some big advantages. First, massive parallel processing. Lots of calculations happening at the same time. Second, communication is local. No long wires wasting energy or slowing things down.
Less travel time for data, less power needed, right?
Right. And third, data gets reused multiple times within the array, so it doesn't need to go to external memory as often. It's a super efficient system.
But wait, didn't Trainium 1 also use systolic arrays? What's new here?
Ah, good catch. AWS took it a step further with Trainium 2. They optimized the power delivery. Instead of spreading it out horizontally, they went vertical.
Like stacking things up instead of sprawling out.
Exactly. Simple change, big impact. Putting the voltage regulators right under the chip reduces impedance, improves power integrity.
So fewer brownouts for the chip, better performance.
Exactly. And as we talked about, better efficiency means lower costs.
We've been talking about one Trainium 2 server, but Project Rainier, that's hundreds of thousands of these chips. How do they even manage all that complexity?
It's a huge undertaking. But AWS, they know how to build and manage massive data centers. The source material emphasizes simplicity, modularity, and robustness in the design.
They even mentioned 0 cables in the server design. Is that even possible?
It's all about minimizing points of failure, improving reliability. Fewer cables, less to go wrong, easier to maintain and upgrade.
And I bet automating the assembly process helps too at that scale, right?
Absolutely.
Yeah.
Every step needs to be optimized when you're building something this complex. But hardware is only half the story. What about the software side?
Yeah, because even the coolest hardware needs the right software to make it work, right?
Exactly. That's where the Neuron SDK comes in. It's a whole set of tools for developers working with Trainium. They have a runtime, a compiler, and developer tools.
Okay, walk me through those. What do they each do?
Sure. The runtime is the foundation, the thing that interacts directly with the hardware. It boots the device, loads models, handles inputs and outputs. Think of it like the operating system for the chip.
Got it. So what about the compiler?
The compiler takes your code, the stuff you write, and translates it into instructions the hardware understands. It also optimizes things so the code runs really efficiently on Trainium, like a translator who also smooths out the language.
Makes sense. And last but not least, the developer tools.
Those are a bunch of resources for monitoring, debugging, profiling your applications. They give developers the control and visibility they need to optimize their code and find any issues.
I noticed the source mentioned they work with PyTorch and JAX teams and contribute to OpenXLA. Why is that important?
Interoperability. Those are popular tools that a lot of developers use. Making sure Trainium works well with them makes it easier for people to switch over.
So it's not about locking people into a specific system, but making it easy to use.
Exactly. Building an ecosystem. They even have the Neuron Next Distributed Library, or NXD, to simplify large-scale deployment.
So NXD helps with those massive clusters we talked about.
Yes. It makes it easy to spread your AI model across multiple Trainium devices using all that power, like an orchestra conductor, coordinating all the musicians.
Beautiful analogy. This sounds powerful, but is it only for experts? Or can, anyone get started with Trainium?
That's a great question. It's designed to be approachable, regardless of your skill level. The familiar tools and frameworks help, and the Neuron SDK has great documentation.
So it's like those complex Lego sets. They seem intimidating, but if you have good instructions, anyone can build them.
I like that. And just like Legos, the possibilities are endless. Speaking of which, let's get back to some of the cool tech behind Trainium 2. I'm still fascinated by sparsity.
Sparsity, yeah. That's the one where it's like only serving the occupied tables at a restaurant, right?
You're right. But Trainium 2 goes even further. It actually compresses the data and skips calculations that involve zeros.
So it's like a waiter carrying a tray with only the dishes people ordered, not a full tray with empty spaces.
Exactly. It's called 4 to 8 sparsity. It reduces data processed, speeds things up, and needs less memory.
And I bet it saves energy too, since it's doing less work.
You got it. All wins. And the best part, it doesn't sacrifice accuracy. They've tested it, and the results are impressive. Huge speed ups, sometimes up to 4x, without any noticeable drop in quality.
It's like getting the same delicious meal, but served way faster. I'm starting to see why they call this a defining infrastructure moment.
It's a big leap forward, and we're just scratching the surface. And speaking of exciting things, have you heard about mixture of experts?
Mixture of experts. Okay, now I'm intrigued. What's that all about?
Imagine you have a team of specialists, each the best in their field. Instead of everyone working on everything, you send each task to the expert who's perfect for it.
So it's like dividing a complex problem into smaller parts and giving each part to the right person.
Exactly. In AI, a mixture of experts model has multiple smaller models, each specializing in something specific. When you input data, it goes to the most relevant expert.
Like having a brain trust, with each expert contributing their knowledge.
Perfectly put. This lets us build much larger, more capable models without the computational costs going through the roof.
Because each expert only handles part of the data.
Precisely. And is more efficient, because each expert is specifically trained for their task, leading to better accuracy and faster processing.
But managing all these experts, that must be tricky, right?
Of course. Ideally, each expert would get an equal amount of work, but in reality, some might become more popular than others, creating bottlenecks.
Like a team where some people are always swamped and others are twiddling their thumbs.
Exactly. Trainium 2 has been optimized for dynamic memory addressing. It can quickly pick the right expert for each piece of data, no matter how the workload is balanced.
Like a smart task manager, making sure everyone's working efficiently.
You got it. And they also have a highly optimized block-sparse computation kernel, specifically for these mixture of experts models.
So each expert gets their own custom toolkit. This is getting pretty complex.
It is, and that's where Nikki-I comes in, the neuron kernel interface.
Right.
It's the key to unlocking Trainium 2's full potential.
We talked about Nikki before. It's that low-level programming environment, right?
Right. Nikki-I gives developers direct control over the hardware. They can write really optimized code, taking advantage of all the cool features, like having access to the engine room of a powerful ship.
So it's not just following a set of rules. It's about giving developers freedom to experiment.
Exactly. They can push the boundaries of what's possible. And to help them, AWS provides the Neuron Profiler.
Let me guess. It's another tool that gives insights into how the code is doing.
You know it. The Neuron Profiler shows every single instruction executed on the hardware. It helps find bottlenecks, optimize performance, understand how the code interacts with the hardware.
Like an x-ray of your code revealing all the hidden stuff?
Perfect description. And it has minimal overhead, so it doesn't slow things down. It's a super efficient diagnostic tool.
Speaking of performance, the source mentioned a real-world example of how Nikki-I was used to get a huge performance boost. Can you tell us about that?
The Mamba 2 example. It's a great story. A team at Amazon was working on a state space model called Mamba 2. It's perfect for handling very long sequences of data, like in natural language processing. Think of it like a model that can read an entire novel, not just a few sentences.
That's wild. But what was the problem?
State space models are sequential. They process data one after the other, which can create a bottleneck.
Like a single-lane road instead of a multi-lane highway.
Exactly. They found a specific kernel, a computational unit, that was slowing things down. They used Nikki-I to rewrite it from scratch, taking advantage of Trainium 2.
And what happened?
They got an 18x speedup for that kernel, and they only used 77 lines of Nikki-I code. It's like they turned that single-lane road into a superhighway.
That's amazing. Real proof of Trainium 2's power and the skill of the developers using it.
It really is. It shows what's possible when you combine great hardware with innovative software. We've explored the how of Trainium 2, the architecture, the software, the performance gains. Now let's move on to the what.
The real-world stuff, how it's actually being used.
Exactly. The source has some cool examples. One that caught my eye is the Lava workload. It's all about image understanding.
So like giving a computer the ability to see and understand pictures.
Yes. Lava takes an image and describes it. It identifies objects, scenes, relationships. Imagine an AI assistant that can tell you what it sees.
Wow. What about creating images, not just understanding them? Can Trainium 2 do that too?
You bet. The source mentions an example using a diffusion model called PixArt. Diffusion models are a type of generative AI that can create realistic images from text descriptions, like an AI artist.
That sounds amazing. So how does it work?
They gave PixArt a prompt, a blue jay standing on a basket of rainbow macarons. It's a pretty creative one.
Yeah, that's a good one.
The model then generated a series of images, getting better and better as it trained. The final result was a stunningly realistic image, just like the prompt described.
So it's not just random images, it actually understands what you want it to create.
Precisely. And this has so many applications. Graphic design, advertising, entertainment, even scientific visualization. The possibilities are endless.
These examples are awesome, but I'm curious about the really cutting-edge stuff. How is Trainium 2 being used in research? What are the big projects pushing the limits?
That's where things get really interesting. The source talks about a collaboration between AWS and Anthropic. They're building a massive Trainium 2 cluster called Project Rainier.
We talked about it briefly before, but the scale is still hard to grasp.
It's mind-boggling, right? Hundreds of thousands of Trainium 2 chips, all connected, forming a supercluster with hundreds of exaflops of compute power. An exaflop is a quintillion calculations per second, a one with 18 zeros after it.
It's like something out of a sci-fi movie. What are they going to do with all that power?
Anthropic is doing amazing work in AI research, developing advanced language models like Claude. With Project Rainier, they want to train even bigger and better models, pushing the limits of what's possible.
It's like building a spaceship to explore uncharted territories of intelligence. But building something that big, it must come with huge challenges.
Oh, absolutely. The Force mentions a few key areas Anthropic is focusing on.
What are some of the hurdles they're facing?
Firstly, new approaches to parallelism. Breaking down a huge task into smaller pieces that can be done at the same time. Trainium 2's architecture helps, but it needs careful planning.
Like coordinating a massive team of workers to build a skyscraper. Everyone needs the right tools and instructions.
Exactly. Secondly, they need to squeeze every bit of performance out of the hardware. Using NICI, the neuron profiler, to optimize the code, find bottlenecks, make sure the chips are running at peak efficiency.
Fine-tuning a high-performance engine.
Right. And third, building really robust testing infrastructure. At that scale, failures are going to happen. They need to detect them and recover gracefully, keep the training process running smoothly.
So like a self-healing system. It adapts and keeps going even if parts break down?
Exactly. It's a challenging but exciting project. The results could have a huge impact on the future of AI.
It sounds like Anthropic is up for the challenge.
Definitely. They have a talented team, passionate about AI. And with AWS's support and infrastructure expertise, they have a good chance of success.
A true partnership, each bringing their strengths to the table.
Exactly. It's all about collaboration, driving innovation.
Right.
But while Project Rainier is still being developed, there are things available right now.
So what can people start using today? What's ready to go?
Well, Anthropic has released a latency-optimized version of Claude 3.5, their powerful language model, running on Trainium 2.
What does that mean for the user? What's the benefit?
Faster response times, smoother experience. They're seeing up to 60% faster input and output processing compared to the regular Claude 3.5, up to 125 output tokens per second.
So Trainium 2 is making AI more responsive, more accessible, right?
Exactly. And this is just the start. They'll be releasing more Trainium 2-powered models soon, bringing these benefits to more applications.
And they did a cool demo using Claude, right, to show off what Trainium 2 can do.
Yes, the coding demo. It's a perfect example of Trainium 2's power and flexibility and how AI can help shape its own future.
Tell me more. What did they do?
They gave Claude access to all the documentation for NKKI, the neuron kernel interface.
So they taught Claude how to program.
Exactly. Then they asked Claude to write a kernel for a specific mathematical function, softmax, and to explain every line of code it generated.
So it's not just writing code, it's understanding it and explaining it. That's wild.
It is. And to make it even harder, they asked Claude to write a kernel for a custom activation function, something Anthropic developed themselves.
So it's using a newly learned language to write code for something it's never seen before.
Precisely. And according to the source, Claude did a great job. The code was accurate and efficient.
That's incredible. It's like watching a student not just learn a new language, but master it and teach it to others.
It really shows the potential of AI, how it can accelerate innovation in unexpected ways. We've covered a lot in this deep dive. The why behind Trainium 2, the technology, the performance gains, and the amazing applications.
It's been a fascinating journey, but there's one more thing to talk about. What does all of this mean in the big picture? What's the impact of Trainium 2 on the future of AI? So we saw Claude writing code, which is pretty mind-blowing, but it kind of makes you wonder, what does this mean for AI? Is Trainium 2 going to lead us to those crazy AI scenarios we see in movies?
Well, it's a powerful tool, no doubt. But at the end of the day, it's still just a tool, right? What matters is how we use it.
So it's not about robots taking over, it's about us humans using AI responsibly.
Exactly. We talked about efficiency, lower costs, making AI more accessible. Those are good things. But they come with responsibilities.
What kind of responsibilities? What are we talking about here?
Well, as AI models get more and more powerful, we got to make sure they're used ethically. Think about the impact on society, the big picture,
Wow.
like jobs being replaced by AI, or even like AI becoming conscious, those kind of things.
Those are definitely part of the conversation. It's complex, so we need to have those discussions as AI keeps advancing.
The source material says Trainium 2 could be a defining moment for AI infrastructure. Why do they say that? What makes it so special?
Think about other big tech shifts. Fiber optics for the internet, smartphone processors for mobile. Those weren't just upgrades, they were game changers.
So Trainium 2 could be the thing that unlocks AI's true potential. Like not just small improvements, but a whole new level.
It could be. It's removing barriers, letting more people experiment with AI, build new things. And with AI writing its own code, like we saw with Claude, the lines between developer and tool are blurring.
Yeah, that's both exciting and kind of scary, right? Like AI is shaping its own future.
It's definitely something to think about. Where is AI headed? But one thing's for sure, we're at a pivotal moment.
So what does this mean for everyone listening? Why should they care about Trainium 2? It's not just about abstract tech stuff. It's about the tools and opportunities that are opening up. Maybe you're a researcher, a startup founder, or just someone with a great idea. Trainium 2 gives you access to power that was previously out of reach.
So it's leveling the playing field, giving more people a chance to contribute to AI.
Exactly. It's not just about building the next big AI thing. It's about using AI to solve real problems, make a positive impact.
This deep dive has been amazing. We've learned so much about Trainium 2, the tech behind it, the potential it unlocks, and even the philosophical questions it raises.
It has been quite a journey. As we wrap up, here's something to consider. What will you build with this power? What will become possible that you never thought could be?
That's a great question to ponder as we enter this new era of AI. Don't forget to check the show notes for all the resources we mentioned today. Keep learning, keep questioning, and keep pushing the boundaries of what's possible. Until next time.